The Timken Company presents Let Her Roll. The Timken Company has been making tapered roller bearings since 1899. You'll find them everywhere wheels and shafts turn, in every type of mobile equipment. From passenger cars to buses, in light trucks and heavy trucks. In this presentation, we'll focus on those bearings most common to heavy trucks and buses. Essentially, tapered roller bearings are used where a housing rotates in relation to a fixed shaft, or where a shaft rotates and the housing is fixed. These two types of applications are made possible by the four basic components of a tapered roller bearing: the cone, or inner ring, the cup, or outer ring, the tapered roller, and the cage that retains the rollers. The cone and cup surface on which the rollers roll is called the race. Now let's see how a tapered roller bearing and its component parts reduce friction. In a typical application, the cone or inner ring is pressed onto a rotating shaft, and it will turn as the shaft turns. The cup or outer ring is seated in the housing and is stationary. The rolling elements between the cup and the cone are the nucleus of anti-friction bearing design. These rolling elements let the shaft and cone rotate within the stationary cup and housing. In this case, the rolling elements are tapered rollers. So as the shaft and cone rotate, they cause the rollers to move or rotate within the stationary cup and housing, minimizing friction between the two. As we mentioned earlier, it's also possible for the function of the cup and cone to be reversed. In other words, the cone and shaft remain stationary, and the cup housing rotates around the shaft. A good example of this would be an automotive or truck wheel. While reducing friction, bearings are required to handle various loads. Some bearings are designed to carry radial loads only, or those applied perpendicular to the axis of the shaft. Where the bearing carries the load is called its load zone. This illustration shows a typical load zone for a radially loaded bearing. The rolling elements are shaded according to the load they support. The darker the shading, the heavier the load. As you can see, the roller marked A is carrying the greatest amount of the load. Besides the radial load, tapered roller bearings also accept thrust load. When the load applied is parallel to the center line of rotation, it's referred to as a thrust load. When thrust loaded, all of the rolling elements share the thrust load equally. However, in most applications, the load a bearing must handle is a combination of thrust and radial loads. Combined thrust and radial loads result in a load zone which is greater than 180 degrees and is non-uniform. Because of the basic design of a tapered roller bearing, it can meet any combination of both radial and thrust loads. Another unique feature of tapered roller bearings is that they can be adjusted to meet a wide range of operating conditions. Most applications require a bearing setting with internal axial clearance or end play. End play provides room for bearing and shaft expansion during operation. Other applications may require a setting known as preload. This is a bearing setting with all internal clearance removed, resulting in a predetermined load on all rollers. No internal axial clearance equals preload. During bearing adjustment, you, the mechanic, have control over setting the bearings to obtain optimum bearing life. Always follow the equipment manufacturer's recommended end play or preload setting. If you allow too much end play, too few of the rollers will be carrying the load. Or if you tighten the adjustment too much, you'll create too much preload or create preload in an application that requires end play. This will put an unnecessary extra load on all rollers. In either case, you'll shorten the bearing